Welcome back. We learned about our basic Python data types. We also learned a little bit about some of the terms that we might use when talking about code. We learned a few best practices, but most importantly, we learned how to perform actions on these data types. We saw that there's built-in functions that we can run on any data type, such as the print function. But we also learned that most of these data types have their own methods. That is that dot, some sort of a name, and then the brackets to perform some actions on them. Now we're still scratching the surface here, but we now go into an area that gets really, really exciting. Because up until now, what we've been doing is this. Every time we write code, we do something here, and then we go to the second line and do something else, and then finally go to the third line and do something else, and so on and so forth. Our Python interpreter just went line by line, one all the way to whatever line number we have on our .py file, and just ran the code. And it ran it really fast because machines are good at that. They run code really fast. But we haven't discovered the true power of programming, and specifically programming for machines. You see, the power comes when we start to incorporate the idea of maybe running multiple lines over and over, or maybe skipping a line and going from line 1 to line 3. And in this section, we're going to talk about the idea of conditions and conditional logic. We're going to talk about looping and loops, where we can perform actions hundreds, thousands, millions of times over and over, something that machines are really, really good at. And that's when programming becomes really powerful, because machines can do certain tasks a lot better and a lot faster than humans. So we're now going to break into a new world, where instead of going from 1, 2, 3, everything in order, we're going to start to break some of that apart so that we have more control over our programs than just going line by line. Let's find out how to do that in the next. Let's talk about conditional logic, an important concept all over programming. What do I mean by conditional logic? We've learned about Booleans, right? We have true and we have false. And some of you might be wondering why they're so useful. And when it comes to conditional logic, Booleans are really, really important. For example, let's say we create a variable, is old. And you know what? We're going to create a car that automatically detects if you can start the engine. Maybe if you're not old enough, the engine won't start and it won't let you drive. So that they make sure that this car is super safe and only people that are perhaps over 18 can drive it. So how can we code something like that? Let's assume Tesla has a new feature like that. Well, we'll have something like is old, and we'll set this to true, right? Maybe we have something else. Maybe it checks the license to make sure that we have a license. So we can say is license. And then we can set it to true. Now, these could change, true and false, depending on the user and the driver. But when I talk about conditionals, this is what I mean. In Python, we can use the if keyword to say if some condition exists, and this is just me writing it, it doesn't exist. You can see that I get a red underline with invalid syntax. But here we want to say a condition that evaluates to true or false. In our case, we can say, hey, if is old, which what does it evaluate to? Well, it evaluates to true. If that's true, then let's say print you are old enough to drive. Now, there's a few new things here. One, I've added a semicolon or a colon, and then you'll see here that the indentation is different. As a matter of fact, when I press enter, after the colon, you see that it automatically gives me a space. This tells the Python interpreter, I'm going to do an if statement, a conditional operation. And if this happens to be true, run everything that's inside of here that has this indentation. And if I do something without the indentation, let's say print check, check, this to the Python interpreter is like a completely new line. It is not part of this if block. And if you're using the REPL, you see over here I get a little minus sign. If I click this, you see how it hides? Well, what it does is it's saying, hey, this is a code block over here. It's an entire thing in itself. But anything outside that is not indented, well, doesn't belong to it. So to a Python interpreter, it's going to say, I have this line, and then I have this line. Let me show you what I mean. If I run this program, I get, you are old enough to drive, and then I also get check, check. But what if I say is old is now false? What do you think will happen? If I run this, I get check, check. Our Python interpreter is going to say, hey, set variable is old to false. Hey, set is licensed equals to true. And then it's going to go to line 3. Nope, nothing there. I'm going to keep going. Line 4, hey, if is old, is this true? No, if old is false. And the interpreter is going to say, okay, I'm only supposed to run this piece of code if this is true. Because this is now false, I'm just going to completely ignore what's underneath here and just go to the next line that has, well, no indentation. So it's going to print check, check. And this is the power of conditionals. We're able to essentially skip lines. The interpreter doesn't even care what's in here because I just told my program to skip from line 4 to line 6. How cool is that? So we learned that there's this if keyword, but there's also another thing we can use called else. And you'll notice here that I didn't add it to the indentation. And else, as the name suggests, simply says, hey, if this something is true, then do this. Otherwise, also else, do this. And again, you see that I've added the indentation. So try to guess what's about to happen in this program. If I click run, I get check, check, because it's saying, hey, is old, is that true? Nope, it's not true. Okay, I'm going to completely ignore that. The interpreter sees else. Okay, well, this wasn't true, so I'm going to run. Whenever this evaluates to false, I'm going to always run print check, check. What if I change is old to now equal to true? What will happen next? Well, I get you are old enough to drive. Else only runs if the if block of code evaluates to false. Very, very cool. All right, let me ask you another question. What if I did print here? And let's change this to you are not of age. If I run this, is that what you expected? Well, I hope by now you agree that this is the expected behavior. Because is old is true, I'm going to print this. And then Python interpreter is going to say, well, this was true, so I'm going to completely ignore the else block and then just go to the next line. What's on line 8? Nothing. So I'm going to go to line 9 and I'm going to print okay, okay, okay. As you can see, we're now controlling the flow of our programs, where instead of going from 1 to 9, just line by line, we're now saying at line 4, do some sort of check, and based on that, skip a few lines. Very, very cool. All right, there's one other thing I want to show you, and it's the if. And I know this kind of looks weird. You would think that it'll be else if, but no, no, no. It's if. And what do you think this does? Well, you use it in combination with if. You say if something, if otherwise, else, if another condition, so let's say is licensed, then do another condition. So let's say print you can drive now. So let's go through this again. I'm going to say, is this person old enough? If that person is old enough and this evaluates to true, well then I want you to run this. Otherwise, I want you to run this condition. Hey, is this true? No. If it's not true, then jump to else. So what will happen here? If I click run, we get true for the first conditional block right over here. So automatically Python interpreter is going to say, well, we just got true here, so I'm going to ignore this and ignore this, and then print okay, okay. But let's say that is old is now false. What will happen next? If I click run, this is false, so Python interpreter is going to say, nope, not going to care about this block. And I'm going to go, hey, else if a condition, hey, is this person licensed? Yep, they are. So I'm going to print you can drive now and ignore else. So it works like this. What if both of these were false? Well, as you can imagine, the Python interpreter is going to ignore. It's going to run this, say, nope, this is false. This, nope, this is false. And then finally, it's going to run this. You see that else is a catch-all. That is, if none of these conditions are true, then we're just going to run this. So it's a backup in a sense. Hey, if all things fail, then just do this. Very, very cool. Now, if you look at this program, you're thinking, this program doesn't really work that well, does it? I mean, we're checking if the person is old and if person is licensed, but shouldn't we check both? We want somebody who has a license and who's old enough to drive. This is a buggy program. If we implement this in a Tesla, well, we're going to get a lot of lawsuits, right? Because we can get somebody who's maybe licensed but isn't old enough, which I guess doesn't make sense. But we can get somebody who is old enough but never got their driver's license, and somehow we get access to the car and they can start the engine and drive, and that's a lawsuit waiting to happen. So how can we fix this? You know what? The power is that this is an expression, right? An expression, if you remember, is something that produces a value. And that means that this doesn't have to, just have true here. It could be an expression. So I could say, if is old and is licensed, then I can do that. And this is something new that we haven't seen before, the and. This is another keyword in Python. And in an upcoming video, we're going to talk about more of these keywords. But this should read like English, right? If is old and is licensed, then do this. So we can now remove the elif. And then here, both expressions need to evaluate to true. That is, whatever happens here, this has to evaluate to true and this has to evaluate to true. And only when both are true, again, as and states, then you're old enough to drive and you have a license. So that if I run this, well, I get an error, right? Because, or not an error, but it goes into the else block because both of these are false. If only one of them is true and I click run, you are not of age because both of these have to be true. If I click run, hey, all right, the car is starting. You can drive away with your Tesla. Okay, before I finish this video, because this is a lot, I want to just note one thing. That is the elif statement. The elif statement is really, really useful because when you have code like this, where you have an if statement and an else statement, usually you only see one of each. I mean, sure, in another part of the program, I could have another if statement and an if statement with another else statement inside of here. But usually, when you have this grouping together, you only see one if and one else, but you can have multiple elifs. So I can have elif, another condition here, and then I can have another elif, another condition here. And you can have as many as you want. Eventually, the program is going to either evaluate one of these conditions to true, or it's going to go into the else block. But usually you follow this order. All right, that was a lot. Let's take a break and explore this topic a little bit more. I'll see you in the next one. Bye-bye. I want to add a quick note about this spacing that we see in this code. Now, this isn't just for Python. In other languages, you'll always see this. You're not going to see that every single line of code always starts as, well, in the first space. Different languages will use this differently, but in order to organize code, usually you'll see some indentation like this. Now, Python, however, is unique because the indentation and spaces that we see here makes the interpreter see it and say, hey, this means something. The interpreter would actually see the space and say, because there's space here, I know that this is part of the if block. In other languages, like JavaScript, well, you have something similar, but usually you'll have an if statement and then some condition followed by, make sure I spell condition right, followed by something like a curly brace. And in here, whatever is in here, you can see that I still get the space and I can do whatever I want. But JavaScript interpreter doesn't really care that there's spaces. If I want, I could write my code just on one line like this. And it's still valid JavaScript code. So people usually do the spacing more for style purposes. Python, on the other hand, is not just for styling that we do this, but because the interpreter actually finds meaning in the spaces, which is actually one of the big selling points with Python. It's very clean. There's no extra stuff here that makes it difficult. I mean, it's just English, right? If is old and if is licensed, then print this. It's just really nice to read and really clean. Now, if you notice here, my editor, and we're going to talk about editors and IDEs in an upcoming section, but if you're using the proper tools, this automatically is created for you. Now, in the programming world, there's this debate about tabs and spaces, and we're not going to get into it. It's frankly a little bit silly. That is, some people prefer to here, if they want to create a space, they might use spaces or they might use tabs. At the end of the day, with Python, the rule is you can use spaces, you can use the tab, but the idea that if you use spaces, you usually use 4 spaces. It's just a standard. Now, if you notice here, I actually don't have 4 spaces. It's 2 spaces here. And that is because up until now, well, I've just been following along whatever this editor gives me. But if you look over here, there's an auto format button. If I click on this, it automatically formats my code into the appropriate format. And you see right over here that I now have 4 spaces. But you see that the code still works. Again, it's because at the end of the day, the important part is that there's a distinction between hierarchies. That is the top and then maybe the children. But the interpreter itself is going to notice these spaces. So you do have to be careful because based on where this print is, as soon as I add a tab in here and I click run, well, I get is old and is licensed. But as soon as one of this is false and I click run, you see that OK runs only if this condition fails. Again, if previously both of these were true, I only get the first line printed. So that little space here changes the outcome of my program. So you have to really be careful with this. And luckily, your editor or where you code is going to help you out with this. But it is a gotcha that if you're just starting out, you want to be mindful of. All right, no more debates about spaces and tabs. I'll see you in the next video. Bye-bye. Welcome back. In this video, I want to talk about the idea of truthy and falsy. What do they mean? And you'll hear this a lot in Python programming. You see, up until now, you've used booleans here as values. So it was really easy. If true and true, then run this code. But Python can do other things as well. For example, if this was 5 and this was, let's say, hello, what do you think will happen here in our program? Well, if I click run, you are old enough to drive and you have a license. Is that what you expected? And this is because what Python does underneath the hood is actually convert these to booleans for you. So it's almost as if it is doing this. Remember type conversion. We're converting the type to boolean as soon as we get to this if statement because Python is saying, hey, I want true or false. I don't care what is old is. I don't care what is licensed is. Just give me true or false so I know whether to do this or to go to the else block. Now, if I was to just print, let's do this here. Let's do print boolean hello. And then finally print boolean 5. Let's see what we get. We get true, true. And this is what we call a truthy value in Python. That is, it's a truthy value because if we run the boolean type conversion on it, it evaluates into true. What's a falsy value? Well, if I do 0 and if I do, let's say, an empty string and I click run, those are falsy. That is, it's not actually false, but it is falsy because if we run boolean on it to Python, it's going to say, oh, this is false. And 0, that's false. And that kind of makes sense, right? Actually, go to Stack Overflow. If you've never seen Stack Overflow before, if you ever have programming questions and you're Googling them, usually the top 5 answers will contain either 1 or 2 Stack Overflow answers. And basically what happens is people ask questions like, what is truthy and falsy in Python? And you get answers. So you can see over here that it has 4 answers. And you usually look for the check mark, which means that this is a verified answer. It means that, hey, this question owner has accepted it as the best answer. So the person who asked this question just said, yeah, this is the right answer. This is the best one. But you also have other people voting. So you can see that this answer received 46 marks. And although it was marked as the correct answer by the user, maybe somebody else came along later on and gave an even better answer. So now we have 123 upvotes. And you see that this answer is a lot better. All values are considered truthy except for the following. So you can actually see here that in Python, these values are considered falsy. You can see 0 here, you can see an empty string here, and then there's a few other ones. Empty set, you have an empty dictionary, empty list, empty tuple. You have decimals. You have things like fractions. You have 0.0. False is that. And also none is falsy. So that if I type in none here, that's false too. Now you don't need to memorize these because most of the time it makes sense, right? But it helps us do conditional logic very nicely. For example, let's remove this. And let's say that we have a user. And this user has to have a password and a username. If, let's say, the username is Johnny and the password is 123. Well, instead of me saying, hey, if this user has password and username, and we're not checking if the username exists or password exists, we just want to make sure, hey, did this person fill out the form and did they try to submit a username and password? I can just simply say password and username. And I don't have to worry about converting this to a Boolean or anything like that, because if password and username exist, then try to log them in. And you see that it reads a lot nicer, because each one of these get evaluated into a truthy and falsy value. It's a nice little feature to keep Python, well, nice and simple and reading like English. I'll see you in the next video. Bye-bye. I want to talk to you about another way to do conditional logic. We saw the if, elif, and then the else statement. But there's another way called the ternary operator. Now, this is still the same as the else if or if else statements, but it's a shortcut. So you can only use these on certain conditional logic. So it doesn't mean that, hey, this is just an entirely new way. This is a shortcut in a sense for you to make your code a little bit cleaner. Let's have a look. By the way, these ternary operators can also be called conditional expressions. And when you hear the word expression, that should mean something to you, right? It's an expression because it evaluates to a value. So a ternary operator or a conditional expression is an operation that evaluates to something based on the condition being true or not. And it's actually a new feature of Python as of version 2.4. So let's have a look. The way we use this is to say is condition, if this is true, then do this. So this is the condition if true. And bear with me here, it is a little bit confusing at first. We say if, and here we give condition, otherwise condition if else. All right, that is a little confusing. So let's go through it. So the if is going to check this condition. So it doesn't actually start with here. It's going to say, hey, if this condition. Now, this is going to evaluate to either true or false. If it's true, then we're going to do this. Otherwise, we're going to do this. So let me show you an example of how that would work. Let's say we're trying to determine if a user is your friend. So we'll say is friend. And here we can set true or false for friend. Maybe we can check on Facebook if users can message you. Or on Twitter, whether Twitter users can give you direct messages. Well, here, and let's do can message. And here we can do our ternary operator. We're going to say message aloud if, so this is if the condition is true. The condition is, hey, is this person your friend? Otherwise, condition that is false, well, I'm going to say not allowed to message. And you can see here that this is a one-liner. It looks like 2 lines, but you can see over here that it's not really. It's just that we're wrapping so we can see the entire code. So let's run this and see what can message prints. If I run this, message is allowed because, well, we've assigned message allowed to can message because, well, the condition was true. If this person wasn't my friend and I run this, not allowed to message because the condition, the if condition, evaluates to false. I know the ordering here can be a little bit confusing, so you might have to look at it a couple of times, and you do need to use it a few times to really remember it, but this is the general rule. Condition if true, if condition, else condition if. Not if else, if false. Can't spell. All right, a nice shorthand way to do something when a condition is either true or false, or evaluates to true or false. All right, I'll see you in the next video. Bye-bye. It's time to talk about another topic that sounds a lot more confusing, short-circuiting, than it actually is. It's quite simple. Short-circuiting looks something like this. Remember when I taught you the word and? So we can use, let's say, for example, is friend equals to true, and let's say is user is equal to true. And I can do an expression here saying is friend and is user. Now, in here, when we run this, let's print it here just so we can see. If I run this, I get true because both of these evaluate to true. So that if I had this as an if block, let's say if it was if is friend and is user, print best friends forever. Now, short-circuiting can be done when we use something like or, which we haven't seen before. But again, you can see here that it's highlighted in blue, so it is a keyword, a Python keyword. Now, or says if either one of these conditions are true, then run this piece of code. So if I run this, I get best friends forever. Now let me ask you this. Which operation do you think is more performant? The or the and? Is there a difference? As a matter of fact, there is because of short-circuiting. You see, when I do or here, because I only care if either one of these is true, the Python interpreter is going to say if is friend, and it's going to evaluate that and say, oh, this is true. And then it's going to see the word or, and it's going to say, hey, I don't care what this is. Maybe this is a really heavy operation or something that I need to look up. Well, I don't really care because this is already true. Whether this is true or this is false, I don't really care because either way, I'm going to have to print this. As you can see, it still prints best friends forever. So short-circuiting happens when the interpreter is smart enough to say, I already did enough work. I don't care what this is. This is just wasted work if I do it. So I'm going to short-circuit and say, hey, I'm going to just ignore this and I'm going to start printing. So using or is a little bit more efficient. But again, it depends on what you need. If you need to check if both is friend and is user is true, you'll have to use and. But this works both ways with and as well. For example, if is friend is false, this is going to get short-circuited because I'm going to say, hey, if is friend is false, well, I don't really care what is user is because there's no way that both of these are true. I've already seen that one of them is false. So I'm going to ignore this and I'm going to print this. And when I say I mean our good old friend Python interpreter. Now, this topic of short-circuiting doesn't really get taught in beginner Python courses, but now if you hear this, maybe you hear this in an interview, as you can see, it sounds a lot more difficult than it actually is. And frankly, it makes a lot of sense, right? We want our machines to be efficient, and it is quite efficient due to short-circuiting. I'll see you in the next one. Bye-bye. Logical operators. And they're very, very useful when it comes to conditional logic. Let's have a look. Logical operators are, well, as a matter of fact, you've actually seen them before. And is a logical operator. Or is a logical operator. It allows us to perform logic between two things. What else is a logical operator? Well, let me list it out for you. We have greater than, less than, equal to. Let's actually use them in an example. Is 4 greater than 5? Well, if I print this, what do you think will happen? Shouldn't be a surprise. That's false. 4 is not greater than 5. This is a logical operator that you may have seen in math class. If I do the opposite, is 4 less than 5? That makes sense. That's true. What about is 4 equal to 5? If I run this, I get false. Now, why did I use 2 equals here? Why not just do this? Well, if I run here, I get an error. Syntax error. Keyword can't be an expression. It's because, remember, equal is what we use to assign to a variable, right? And if you remember, I told you that a variable in Python can't start with a number. It has to be a letter or underscore. So when I do this, it's going to error because the interpreter is going to say, hey, I'm trying to assign variable 4 the value of 5. And, well, that's not really allowed. So we use double equals to tell the interpreter, hey, I'm not assigning a variable here. I want to compare things. And we can compare different things. I can do hello equals to hello equal to true. What if I do A is greater than B? I get false. Now, why is that? This I want you to Google on your own and figure out why is A greater than B. What if I do A, is that greater than capital A? That's true. This is interesting. And this is actually quite an interesting reason. So I know it's easy for me to just give you an answer, but I want you to practice Googling this. And the reason I'm not giving you an answer is it's also because it's not very important. Because most of the time, you want to make code that is easy to understand and understandable. You're most likely using greater than and less than with numbers. So if you see something like this in code, well, you wouldn't know what's going on. What is this person trying to compare? Why are they doing is lowercase a greater than capital A? It's not something that you see very often. But the reason you get this expression is quite interesting. So I do recommend you Google into it. Like I said, I'm a strong believer in not holding your hand the entire way. I know so far the videos up until now have been quite easy, especially if you are an experienced programmer. But as we progress, you'll see that after this course, you need to figure things out on your own. And my job is not to just handhold you the entire way. It's to develop the skills in you to become an employable programmer. So I hope you bear with me as I just give you this little challenge. All right. We went a bit on a tangent, so let's bring it back. Can I do things like this? Is 1 greater than 2? Or you know what? Let's do less than 2 and less than 3 and less than 4. Will this work? Well, of course it will. It's just an expression, right, that we're evaluating. And all of this is true, but as soon as I change and something is false, it's going to short circuit, which we learned about previously, and return false. All right, so we know the greater than, equal to, less than sign. We also have greater than or equal to. So that if I do 0 here and I click run, I get true because it's saying, hey, is this greater than or equal to 0? I can also do less than or equal to 0. And here I get false because 0 or 1 is not greater or equal to 0. But if I do 0 here, I'll get true. Here's another one. What if I do this? Exclamation mark equal. This means in Python not equal to. If I run this, I get false. And this is a little tricky. What it's saying is, hey, is this not equal to this? So it's the opposite of doing equals. If these two things don't equal, it's going to say true. So if I do 1 here, I'll get true because these two things do not equal. So we've learned greater to or less than, greater to, equals, equals or greater or equal to. We've learned about less than or equal to, We've learned about not equal to, but we've also learned about and or. And finally, there's one more I want to teach you, and it's the not keyword. I know, it's a little much, but it's not as hard as you think. Not is, well, the opposite. So if I do here, not true, what do I get? I get false. And you see that not is also a function. So it's a keyword, but also a function that we can use. If I do not false, again, I just get the opposite. What if I do this? What if I do not 1 equals to 1? What will I get here? I get false, because this expression evaluates to true, and then not just does the opposite. So let's take a break here and work on a little bit of an exercise to make sure that we understand this. Welcome back. Let's do a fun little exercise. We just got hired by a gaming company, and we're creating this wizard game. And this wizard game has the is magician in the user's profile, and for now we'll just set it to false. We also have is expert. And whether this user is an expert at this game, we'll leave it at true for now. And then let's do this here. I want you to check if both, or check if magician and expert. And if that's the case, if true, then I want you to print you are a master magician. And also I want you to check if magician but not expert. If that's the case, I want to just print at least you're getting there. And then finally, let's do a check that says if you're not a magician, I want you to say, well, you need magic powers. Now, I want you to use what you've learned about logical operators to create this conditional logic. You can pause the video if you want and try it yourself in a REPL. Otherwise, I'm going to keep going with an answer. But you should be able to solve this fairly easily if you've been following the videos and exercises so far. So let's start with the first one, where we say you are a master magician. So I'm going to say if is expert and is magician, I'm going to print you are a master magician. So I'm going to copy that and say print you are a master magician. Nothing too crazy here. And then next one, I'm going to say if, or I could even say elif if I want. And again, this is something that you can decide what you prefer. I usually like using elif if it's part of the same concept as the first one. In this case, yeah, we're still trying to figure out what type of user it is. So we'll use elif and we'll say elif. We want to check if it's a magician. So that is magician. So we're going to check if that's true. But we also want to check if, well, not an expert. Now, how do we do this? I mean, we could say use short circuiting and say is expert. And even if this is false, we can get true here because is magician, short circuit, and print this part. At least you're getting there. Because the interesting here is that this code block is never going to run if both of these are true, because in the first if block, we're checking that. So that as soon as this is true, we're going to completely ignore the elif. So we could do that, but This is a little bit hard to read because I really have to think about it. If I come back to the code or somebody else looks at my code, it's not clear that unless I comment that I'm checking if it's magician but not expert. Because this will never run if is magician is false, then that's what they're checking for. I know it's kind of confusing even saying it. So I prefer using something like this, using and not. And that reads a lot better, right? It makes a lot more sense. Hey, if this person is an expert and magician, do this. Otherwise, if this person is magician and not an expert, then print this. That reads pretty nicely. And yes, you can do this because remember, not is simply checking and inverting whatever the Boolean expression is. So this still evaluates to a Boolean that and can check. All right, let's finish the final one. If you're not a magician, you need magic powers. So how do we check here? Well, we can do another L if and say not is magician. And if I run it like this and say print, and we'll just copy here, you need magic powers. And let's remove the comments for now, just so we can see the blocks of code. And we're going to test our program. Hopefully we coded it properly. Hopefully there's no bugs, but let's have a look. If I run this, you need magic powers. Why is that? Well, if magician is false, none of these are going to work. What if I change this to true and I click run? All right, I am a master magician because I'm an expert as well as a magician. What if I turn this to false and I click run? Hey, at least you're getting there. I'm a magician, but I'm not an expert yet. I still need to improve my gameplay. Now, you may have gotten a different answer than me. And there's many ways to do this, right? You could have used an else statement. You could have used or. Conditional logic is all about writing code that makes sense, not only to you, but for other people reading your code. The idea is not to be extremely clever or really worry about short-circuiting. Yes, it can be more performant, but a machine is so powerful that just tiny bit of optimization there is usually not worth it when you're losing perhaps readability. So you want to make sure that your code reads like English. And this is a topic that, frankly, a lot of beginner programmers have a hard time understanding, where they try to be as clever as possible, write as little code as possible in the shortest possible lines, when instead you want to focus on readability. Because a code that is easy to understand is a sign of a good developer. And I hope looking at this, you're thinking, yeah, this is pretty easy. I mean, this all makes sense. But this is not the only way. Maybe my version of what reads well is different than yours. The idea is to each of us try our best to make our code simple and nice. And in programming, there is no one right answer. There are many ways to solve a problem, but the key is to solve it in a simple manner that is readable. I hope you had fun, and I'll see you in the next one. All right, in this video, I'm going to try and trick you. I want you to look at these expressions where I'm checking for equality, right? I'm saying, hey, does true equal 1? Does empty string equal 1? Do two arrays equal that are empty equal, well, each other? Now, pause the video here and try to guess what the outcomes of this are going to be. Ready? By the way, if you get 100% on this, well, good for you, because if this was my first time learning Python, I wouldn't get this. Let's go. Is that what you expected? True evaluated, so true equals 1, evaluated to true. An empty string equals to 1, evaluated to false. That makes sense because they definitely don't equal each other, right? An empty array doesn't equal to 1. And a 10 equals 10.0. And then both arrays that are empty equal to true. Now, the reason I'm showing you here is that the double equals checks for equality or equality of value. That is, if, for example, the first one, true equals to 1, there's two different types. One's an integer, one's a Boolean. It will convert them into the same type. In this case, this will be converted like this to a Boolean value. And if you remember, 1 is truthy. So this will evaluate to true, which is why we get true. What about the other one? Well, an empty string is falsy, so it evaluates to false, and false doesn't equal true, right? Because we're checking for equality here. So one of these gets converted to the other's type. What about an empty array? Again, an empty array is actually falsy. So that's not going to equal 1. A 10 equals to a float of 10.0. That gets converted to an integer or a float, and they're going to equal each other. And that's an expected behavior. And then an empty array, well, equals an empty array. If I add in this array 1, 2, 3, 1, 2, 3, and I click run, I get an invalid syntax. Oh, because I have this here. Let's run that again. I get true. That makes sense. Let's change this to 1 and see what happens. If I click run, all right, still false. Now, this does get a little tricky, right? Like, should this have evaluated to true? But no, we get false. So this doesn't get converted in type versus what we had here. Now, don't get confused by this because this would be bad code. If you're checking something like this, well, obviously you should be checking two types, two of the same types together. Ideally, when you use comparison operators or logical operators like this, you're comparing two types and you're not letting Python do this type conversion, and hopefully Python figures it out for us. But I hope the double equality makes sense, because there's another check that we can do, which is. And is, well, is a keyword in Python. What happens if we change all these equal signs to is? Do you think there would be a difference? Let's have a look. If I click run, I get false for everything. So what's the difference here? Equals checks for the equality in value, such as 1, 2, 3. Well, that has the same value as 1, 2, 3 in a list. Is actually checks if the location in memory where this value is stored is the same. Let's go through that. So true, is that 1? No, true is not 1. True is, well, only true, right? That will be true. What about string 1? Is that 1? No, I mean, for 1 to be a string, that needs to be 1, right? Because the 1 string isn't only in one place in memory. It's literally the exact same thing. What about this list? As a matter of fact, let's do is array, empty array. Is that, or is this list a list? Well, if we run this, I still get false. And this is a little tricky and also advanced. Every time I create a list, it's added in memory somewhere. So this is in a location in memory. But whenever I create a new list, it's created in another location. So these are two completely different lists that live in different locations in memory. So it's going to check, hey, is this in the same memory space, same bookshelf as that one? Nope, that's not it. But why does this work for things like numbers and strings? And that's because underneath the hood, These are types that are very simple that are in memory but in one location. Versus something like a list, even though this might be the same list with the same items, because this is a data structure, every time we create it, it's created in a new location. So that even if we have a variable A that contains this list, and by the way, this will be the same for all our data structures like dictionaries, sets, tuples. If I do B equals this, and I check A, is that B? Nope, they're created in a different memory space. So this, where A points, is in a different place than where B points. But if I do A equals to B, I get true because this double equality checks only the values. Now, this is a bit of a hard topic. So you might have to watch this video a couple of times. You might have to practice this a few times yourself. But just keep in mind the difference between is and double equals. Is tends to be a little stricter. You're checking for the exact thing that you're looking for versus equality, which checks the value. All right, that was a doozy. I'll see you in the next video.